Hello and welcome. Today I'm going to take care of this 286 machine, which was claimed non-functional by the previous owner. At first glance, it looked to be nice and clean. However, as you can see, there was already some damage visible. The holders were broken and had to be fixed somehow. The look inside offered that everything was pretty clean. Too clean, if you ask me. I think somebody was here before not so long time ago. The CAF stickers on the BIOS tell that this mainboard must be the original one. Among the components inside there was a 10 megabits network card, a multi-I/O controller for hard and floppy drives, and this nice VGA graphics card. It has an exotic name, Acumos AVGA2. However, this is actually a rebranded Cirrus Logic CLGD5402, quite fast and reliable VGA card. There was also integrated multi-I/O controller directly on the mainboard. So someone was definitely here before and added the additional controller, probably because the onboard controller was defective. As you already can see, this PC suffered of heavy damage as a result of a leaking battery. Even the case had rust in that area. Yeah, the mainboard didn't look great at all. Oxidation wherever you look. Here is the reason of the disaster, the barrel battery. Here I already saw a lot of damaged traces. Well, it looked bad, but I still wanted to rescue this mainboard. The 32 MHz crystal oscillator, which delivers the clock to the CPU, revealed that the CPU was probably clocked at 16 MHz, since it usually works with half of the frequency of the oscillator. And as you can see, my assumption was right. We have a 286 CPU with a 16 MHz made by AMD. It's nice that it has a heatsink, means it will last longer and can probably be even slightly overclocked. Let's move on. Here is the front panel again. As you can see, the stands were completely broken. That was quite unfortunate, but fixable. The hard drive was not fixed. This 5-inch floppy drive looked quite good. The case had additional hole for the 3.5-inch floppy drive, but unfortunately the cage inside of the case to hold it was completely missing. First, I removed the rust from the case using a Dremel. Looks like somebody was already trying to get rid of it. I put some rust protective paint on the spot to protect it from further oxidation. I probably should have used a brush for it, but I don't care how it looks like, since it is hidden inside under the mainboard. Now let's take a look at the mainboard again. First, I remove the battery. Before turning on an old mainboard, always check for shorts first. All 5-volt rails were okay and seemed not to have any shorts. You hear a short beep when testing these rails, since they are connected to the ground through some capacitors. However, on the 12-volt rail, the yellow cable, there was obviously a short. Since the traces were covered by the power connector, I removed it to be able to follow the traces properly. After washing the mainboard with soap and water, I cleaned the surface and contacts with white vinegar. After drying, I could make a better picture of all the damage. The verdict: a lot of heavily damaged traces. This blown capacitor was responsible for the short on 12-volt rail. Many small parts were missing, like this transistor on the back of the mainboard. Quite a lot of damage if you ask me. However, I didn't want to give up too fast. I replaced exploded capacitor, resolved the short, added missing parts, fixed some broken traces. All in all, I invested many hours trying to get it working. I did some progress, but unfortunately the damage was just too much. In the end, I replaced more and more capacitors because during the test they blew up and issued another short. I removed some parts to be able to repair the traces properly, but after a while I had to give up to move on with this project. Instead, I decided to go with this Octect 286 mainboard. It is very fast and reliable mainboard, which I repaired some time ago. I also modified it to be able to use a cell battery CR2032 instead of this stupid barrel battery. It has 2 MB of memory, what is more than enough for a 286, but the CPU is only 12 MHz, which is 25% slower than the original one. Unfortunately, the socket type is different, so I couldn't just swap the CPUs. All the other hardware in this PC seemed to me not to be original anymore. So I decided to go completely with my tested components. Since the mainboard is based on Headland chipset, I decided to go with Headland VGA card. Not that it is important somehow, but I found it's nice to have. The Super Multi-I/O controller for the drives and I/O ports in combination with the hard drive, which was in the PC already. An additional gimmick is the Sound Blaster Pro compatible sound card with ESS chip. It doesn't have a joystick port, so I decided to take another I/O controller which would provide it for me. This also has additional parallel port, but this is not an issue if set up properly as LPT1 and LPT2. Now to the power supply. After I plugged in the power cable and checked the input voltage, which is on 230 volts as I am in Europe, I turned it on and it didn't make anything. It seemed to me completely dead. I opened it and found a shorted diode in some more parts burned black. Usually, I prefer not to mess around with high voltage. Same in this case, after some minutes I decided just to go with another working power supply, since I have a box full of them. I just had to clean it, since it was full of dust. And I had to oil the fan. In the end, it was as good as new and nearly silent. Back to the front panel and broken off holders. I decided to go with the super glue, since the surface was big enough. To improve the stability, I decided to try something I heard about before, the baking soda trick. First, I cleaned the surface with alcohol, added some super glue and pressed the holders in place. After some minutes, I added some more super glue around the base of the holders and gave a teaspoon of baking soda on it. Probably it was too much, however, the super glue seems to react with baking soda and instantly build stone hard compound. This is absolutely non-applicable for flexible parts, I guess, but for the broken static holders, in this case, it made great job. The original CAF mainboard has proprietary connectors for the case LEDs and the reset switch. I had to rewire the cables and slightly modify the panel to fit the new Octect mainboard replacement. Putting everything back together went quite easy. After some tests off camera, I decided to go with another multi-I/O controller and joystick as well as additional server port connected via cable, avoiding the need to install two cards and messing around with ports, addresses and other resources. As you probably remember, I needed a joystick from the I/O controller because the sound card doesn't have any. The chosen sound card gives a good sound and compatibility to Sound Blaster Pro. To get a better sound quality, you should always try to insert a sound card into the last ISO slot to minimize electromagnetic interferences. The 5-inch floppy drive I needed for another project, so I decided to go with 3.5 floppy drive instead. As soon as I installed it in place, I decided to do something different. For my idea, I needed to place the floppy drive into a vertical hole. Unfortunately, there was no cage inside the case to hold the floppy drive in place. However, I could find one in my metal scrap. The hole for the screws didn't fit, But with a drill, this was an easy fix. Into the free 5-inch hole, I decided to insert a Gotek USB floppy emulator. I have a couple of them with pre-installed flash floppy firmware. This gives additional freedom to keep up to 1000 floppies on one USB flash drive. After connecting all the cables, the PC was ready for the first test. Unfortunately, the hard drive turned out to be dead, despite that it worked before since I tested it off camera. Anyway, this is an old hardware, and such mechanical drives were never made to work so many years. I decided to replace it by a modern solution, which I prefer for all of my retro machines, compact flash to IDE adapter. This one is mounted on a metal bracket and can be placed in rear slot, making it possible to exchange the compact flash cards without the need to open the case. This is very handy if you want to copy some files from a modern machine or want to play around with different software setups. One problem I got here though, the power supply didn't have enough power connectors to connect all the devices. Anyway, with a workaround, I was able to boot into pre-installed DOS. After a successful first run, I had to take care about the power supply. Again. Well, I had now 3 disk drives to connect to. The 3.5-inch floppy drive, the Gotek USB floppy emulator, and the compact flash to IDE adapter. All of them don't use such wide Molex power connectors, but these smaller ones and this power supply I've chosen had only 2 such connectors. There are adapters from such bigger connectors to smaller ones out there, but I didn't have any. However, as I told before, I had a box full of power supplies, and I found another one which actually had 3 connectors I needed. After assembling everything and even doing some cable management, the PC was almost ready to fly. But I had another 2 issues to solve. First one is more a cosmetic issue, the gaps in unused slots. I had to cover them somehow, but I didn't have any dummy brackets. Second, and more critical issue in my opinion is that this PC didn't have any turbo switch. It had a LED, but no switch. Well, 286 is not really a monster machine, but it is still a lot faster than the original XT PC made by IBM back in the days. And if you would like to play an old game from that time, this 286 would probably be just too fast. As usual, also the Octec mainboard has a connector for turbo switch, and as you can see, if I short it with a screwdriver, turbo LED goes off. So I wanted to add a physical turbo switch, but I didn't want to drill holes into original front panel. So I decided to combine the issues and put the switch on the back into one of the slot brackets closing the gaps. Getting some brackets was an easy task. I just salvaged them from the old modems, which I have in piles. I made a hole in one of the brackets and added a switch. I covered the old modem cable holes on the brackets using some electrical tape. And after some soldering, the brand new turbo switch was ready to use. Here you can see the tool landmark shows about 18 MHz and the yellow turbo LED is turned on. If I flip the turbo switch on the back, the LED goes off and the benchmark falls down to about 9 MHz. When I flip it back, it goes up again. Nice. Actually, at this point I was quite satisfied by the result. However, the fact that I couldn't rescue the original mainboard bothered me a lot. I invested a lot of time without having the original heart beating in this nice machine in the end. That was really disappointing. Furthermore, the original CPU was 25% faster, and I asked myself if I could transplant the CPU from the old mainboard to get at least a part of the old machine working again, in this case, and also to get 16 MHz instead of 12 MHz CPU. I had no guarantee that the old 16 MHz would work at all, but I found the idea quite funny and decided to take the risk. Desoldering the CPUs and soldering one back was not a problem at all. With a desoldering station, this is really child's play. You just need to be patient and preserve the polarity when soldering the sockets into the main. After the transplantation, the first test went without an issue. The old 16 MHz CPU turned out to be functional. The mainboard started properly, complaining about missing graphics adapter with 8 post beeps. The heatsink of the CPU remained cool. I left the old crystal oscillator for the first test, so the CPU worked actually with 12 MHz anyway. Everything connected, I turned the system on again and went into Landmark. There I saw the benchmark pending around 18 MHz again, just as expected. Sysinfo showed also 12 MHz and 8.9 points in the benchmark. I tried Wolfenstein 3D to get a feeling about the performance. Let's say it was quite choppy, but kind of playable. After the first try, I replaced the crystal oscillator. Unfortunately, it's not good visible, but the old oscillator delivers 24 MHz, means 12 MHz for the CPU. The oscillator from the original CAF mainboard, where I got the CPU from, the oscillator delivers 32 MHz, means 16 MHz for the CPU. After turning on the system, I could find 16 MHz in Sysinfo, and its benchmark raised to 12 points from 8.9 points before. This is a linear improvement around 25% as expected. The same in Landmark. The benchmark went up to 24 MHz from 18 MHz. Despite that these megahertz numbers are not real, here we even see an improvement of 30%. I guess this is due to higher frequency on the bus, since that is also controlled by the same oscillator. Now the real test again, Wolfenstein 3D. This feels a lot smoother and is now much better playable. At that point I was eventually done with the hardware. Everything assembled, the PC looked like this. In the last slot there is a compact flash card. The gaps are closed by the brackets salvaged from the scrap. Here are the I/O ports, 2 serial ports, 1 parallel port and 1 joystick port. Here is the VGA port. Here's the turbo switch, and the last one is the sound card with the volume regulator and all the audio in and output. After all, it was time to install DOS. I have all installation disks on the USB drive, which I used with Gotek USB floppy emulator. The DOS version I have is a German one. I still have the original disk from my first PC, which I copied to the USB drive. The installation went without an issue. It is really easy to switch between the disks on the floppy emulator. After setting up AutoExec and configsys properly, I got the sound card working, as you can see here. I decreased the size of the window in Wolfenstein 3D because playing with the sound added some noticeable overhead. All games I tested worked without an issue. The system remained stable and fast. Well, as fast as 286 can be, obviously. Anyway, this is it for me. I hope you enjoyed watching this video as much as I did doing this project. Please leave your comments below and tell me if you like this video and would like to see more like this one. Or not. So far, thank you and goodbye.